Okay, now let me just give you the answer. Well, let me just give you the hint. This is a linear sequence. With the linear sequence yesterday, this is just a short recap. Okay, can somebody just tell me what's the formula to figure out the nth term? Okay, can somebody just tell me immediately? You know, it's going to be something n plus negative 7n. How do you get that negative 7?
Because
The differences is negative 7. So this coefficient in front of n is negative 7. Okay? Plus 48. How do you get that?
Because the difference from negative 7 to 41.
Yes, just think about this question when you try to figure out this number. How to get a 41, this one, with negative 7, okay? When you think about this question, how to get a 41 with negative 7, you have to add, 48, right? Because negative 7 plus 48 would be equivalent to 41. So this 48, positive 48, is value for the second term. Okay, that's the method given by the textbook, right? Which is so simple, so straightforward, but it doesn't explain the principle behind it, and you cannot apply to what we're going to learn today. Quadratic sequence. With the quadratic sequence, this is the learning objective. After this lesson, I'll give you a series of numbers, a sequence, and you're going to find the formula like this. UN sequence is equivalent to AN squared plus BN plus C. Okay? It's getting harder, right? Because you haven't learned the quadratic equation before. But it's not that hard. It's not that hard. Now, I need you to help me recap what we did yesterday. All the process we used to find the formula of it. Step 1, we have to analyze the sequence, and we have to determine what the sequence is. Is it linear or quadratic? We have to test first. Step 1, determine the sequence. Okay, there are two methods we use. What's the first one? Substitution. Yeah, substitution. What about the second one? Slope. How about, we draw the graph yesterday, right? And by reading the graph, we know it's a line. If it's a line, it's linear. So the second method, I'll say graph. Slope is actually also part of substitution. Okay, let's just draw the graph, which is you just draw a graph x and y and plot all the points on the graph, right, to figure out that. So I'm not going to explain too much with this part. We focus on the step 1. Okay, the first method. Step 2, let's start with substitution. What do we do to work on the substitution? Plug in what? This is the first, second, third term, yes. Fourth, fifth, until the nth term. Nth term, and we have a value for it, right? That's going to be UN, right? Now, for substitution, what do we need to do? Wait, hold on. We got something wrong here. Determine the sequence. Determine the sequence. How do we determine the sequence? What's that? Look at the what? Find the differences. This is actually part of the process too. Let me just explain. Here is that. Nobody correct me, nobody get a point. Find the differences. Okay, so we just need to look for the differences of all the numbers here. What's the difference of here? -7, right? Positive is -7. So if they're all the same, okay, this is what we call these numbers first differences. I'll just write down first DS. First differences. If first differences are all the same, it's linear. Yes, it's linear. Now step 2, find the formula of the linear sequence. Right? Since we know they're all in the linear sequence, so we're going to use the method for calculating the linear formula of linear sequence. So 2 methods, substitution and graph. And yesterday we mainly talked about substitution. So step 3, let's just work on substitution. You know, for substitution, you're going to, linear, what's the standard format? What's the standard format of the linear sequence, the formula?
Y equals mx plus c.
Yeah, that's a linear equation. Y is equal to mx plus c. With this one, we can derive the sequence. What's the sequence formula? What's that? Un is equal to mn plus c. The n stands for the nth term. The un stands for the value on that term, right? Then what do we do with this formula, with this equation? Any idea what we did? To find it, to substitute 2 values, 2 points. This is the first point, second point, and this first, second, they're what in the equation? They're what in the equation? They're n. What about this? 41 and 34. Un. So we got 2 points. We got 2 points, 1, 2, and we're gonna substitute these 2 points in the formula, and we get what? The first one, if we substitute the first point in the equation, we get what? 41 equals to n plus c.
Oh, no, n plus c.
Yes. To m plus c.
Not two, m. 1.
Just one. 1 times sign, right? What about the second one, logos? If you plug the second point in the formula, what do you get? 2m plus c. Okay, now equation 1, equation 2. This is a simultaneous equation, right? Or it has another name, we call it 2 by 2. Just use another. This is also called 2 by 2 system equation.
Do we have to write it down?
Yes, please. Because we're going to use this similar method to figure out the quadratic sequence this time. And then what do you do to solve m and c substitution?
Plug in.
Okay. You can use 2 minus 1, it's going to be elimination, right? To cancel c. The core concept of solving system equation is to reduce the number of your variables. Look at this two, it has two variables. 1, 2, right? 1, 2. But you also have two equations, 1, 2. So 2 by 2, if the number, okay, let me just write it here. 2, this is two variables. Variables and equations. 2 by 2. If your number of variables is the same with your number of equations, your problems can be solved. Okay, keep this in mind. Only when your variables is equivalent to your equations, your problem can be solved. Okay, keep this concept in mind. We're going to use the same concept to solve today's quadratic sequence. Okay, now let's get back to this question. 41 is equivalent to 1m plus c. 34 is equivalent to 2m plus c. Okay, how can you do to solve the first variable? You can eliminate it. You can substitute it. Just share with us your method. So you which equation you're using now? First one? First equation, okay. So you can say from 1, you got C is equivalent to 41 minus m, right? Then you what? Substitute. Let's give it number 3. Substitute 3 in equation 2, right? And you just replace the C with this equation. That'll be 34 is equivalent to 2m plus 41 minus m. Okay, now look at this equation. It's what? It has only one variable. One variable, one equation. So the problem can be solved. And it has a specific name. It's called a linear equation. Linear equation. And 2 by 2, we call it simultaneous equation. Simultaneous equation. Now, what's your value for m? So you -7. It's early in the morning and your CPU is not working well now.
It's morning. It's just turned on.
you gotta update your hardware. Yeah. Okay, you got the value for m, then what you need to do? You can plug your m to this one, or this one. They all work. They all work. So let's say plug m is equal to -7 in, just plug in the first equation yourself. And you got 41 is equivalent to, it's no longer m, it's what? -7. 1 times -7 plus c. And your c is equivalent to, okay. So you
Yes.
What's that?
Did you see the smoke coming out of his head?
Is that 1x?
What?
The 1x. Oh. -2. Is it?
What?
Oh.
Huh? Okay, rewind.
Why is there math in the morning?
Linear equation, come on. 41 is equivalent to -7 plus c. What's your value for c? You can just cancel the c, make c the subject of the equation. What's that? Elijah? 48. 48. Yeah, you got it? Okay, you got the value for M, you got the value for C, then your equation would be what? That's last step, step 4. UN is equivalent to, let's go back to here. Your M is -7, your C is 48. Then your equation becomes UN is equivalent to -7 N plus 48. That's it. I mean, it takes longer time for us to determine what the formula is, but it works for all of the sequences, no matter it is linear, quadratic, even cubic. Let me explain why.
In the future.
So why is there few extra variables on the quadratic?
Can you say the question again, please?
Why are there extra variables on the quadratic?
Okay, good question. Good question. Because that's just the standard form of.
Because you say if the substitution works.
Yes, good question. Y is equivalent to ax squared plus bx plus c. This is the standard form. It covers all of the types of quadratic equations. It can be y is equivalent to 3x squared plus 6, y is equivalent to 3x plus 10x, y is equivalent to, it can even be y is equivalent to, say, 2x plus 1. I mean, you might get, it's weird now. This one is just a linear equation, right? But y should be in the range of quadratic sequence. Okay, when your value for b is 0, there's no term for bx. So you didn't see a bx. When your c is equal to 0, you don't see a constant, right? C is just 0, it gets cancelled. When your a is equivalent to 0, ax squared just gets cancelled. There's only linear equation left behind. So this is the standard form of quadratic sequence, quadratic equation. Okay, we're going to explain more on that. Now, okay, keep this in mind. I'm going to erase that. And this is the key for us to solve quadratic sequence. Let us move on to the next level, okay? I'm just going to erase this part. I'll keep the process here because solving quadratic will be similar to solving linear. Okay, you can just give you a reference. Erase out here. Let me use this question. Okay. Okay, example 2. Get this on your notebook. 4, 1, 0, 1, 4, 9. What about 6 times 9? What?
6 times 9?
No.
I can't.
So,
6 times 9, 54.
oh, you're correct. You're correct.
She just said that!
You're correct. My brain is not working well now. Okay?
Can't use a clock. You get it.
No, I'm the teacher. I can use it.
14, 900K.
Oh no, you needed 2 more. 2 more. Yeah, you just get 1 correction. Yeah. Okay, tell me the formula. Find the nth term of this one. Un is equivalent to an squared plus bn plus c. Tell me the formula of this one. And this is the first term, second term, third term, fourth term, fifth one, and the sixth one. Okay, this is a process for solving linear equation. It doesn't have, it just gives you a hint for solving this one.
Does that mean you need 3 terms? Because there's 3 variables.
Yes. Not 3 terms. Not 3 terms. But you got a good start. 3 variables.
No, because there's 3 variables on that equation.
Yes. So good question. Remember that? To solve system equation. System equation. If you want to solve a system equation, your number for variable has to be equivalent to the number of equations. If your variable have 2, you're gonna need 2 equations. If there are 3 variables, you have to have 3 equations.
How would you substitute?
Yes, yes. Substitute 2. Substitute 3. I'm gonna explain that. But you get a very good beginning. Great, great. Now first step will be the same. If I just give you this bunch of numbers without telling you what sequence it is, you have to determine what sequence it is. Determine the sequence. That's the same process with linear. How would you do to find the determinant sequences? Well, how would you do to determine the sequence? Divide. Yes, find the difference. Okay, let's find the difference together. Tell me the number, Lotus.
-1 plus 3 plus 5
What?
plus 3 plus 5.
Okay, good, good. Now, you see, the first differences, first DS, they are not the same. They're not the same. What do we do? Find the second difference. Second DS. Okay, Jonah,
Yes.
what's the difference of the first difference?
Difference of first difference?
Yes.
2.
You got it? You got it? Positive or negative, tell me.
Positive?
Okay, what about this one?
Plus positive 2.
Good. What about this one?
Positive 2.
Good.
Positive 2.
Okay. So you see that the second differences are the same, and it's telling you this sequence is a quadratic sequence. Second differences are the same. Crazy, right? Okay. It's quadratic sequence. Okay, let me tell you this. If your third differences are the same, then it's a cubic sequence. It's getting weird, right?
Yes, it's getting creepy.
It's getting very weird. If you have spatial differences, like if you have spatial sequences, like you're gonna, for example, I mean, you're not going to have a fixed value for the differences, which is even, which is beyond our current level now. But let's just focus on the second one.
Yes.
Okay, step 2. What's the step 2? Look at the steps for solving. Finding what? Finding what? Find the formula of what? Of the quadratic sequence. Second difference is.
So you just need to extend it like 1. Like just that.
Yes. Yes, you got it. You got it. So a two-way substitution or algebra. It's more on algebra because we didn't draw any graph. If you don't draw any graphs and you just use, all these letters and numbers, it's called algebraic way. Algebra and graph. Now let's just talk more on the substitution, and later I'm going to explain how it looks like on the graph. Now I'm going to erase this part, okay? Step 3. You know that the formula is going to be un is equal to an squared plus bn plus c, and you know that there are going to be 3 variables in this equation. And Elijah just mentioned now, how many equations do you need? 3. You need 3. So let's just look at, we just need 3 variables. The number, okay, I might need to keep constant. I might need to use this one. The blue, okay, look at my blue N over here. It represents all the terms, position. And I'm going to use the black to indicate the value of these terms. Now, with nth term and un, you get a first point, a second point, and third point. Okay, great. Now, let me just see. 1, 4. Okay, this is n, this is un, right? And 2, 1. Okay, that's second point. The same. N, un. And the third one would be 3, 0. N and un. Okay, now we're going to plug all of these 3 points in this equation. And we got 3 equations. Plug us, and you just, now Evelyn, tell us what are those 3 equations if you plug them all in.
4 equals
4 equal, okay, the first one.
1 plus
1 and, no, 1a, yeah, you're correct. 1a
plus C.
what? Plus c. What about this one? Just get rid of it.
B1.
B1, or you can say 1b plus c. You know that 1a, 1b is just a and b, right? We can just ignore that. Okay? That's the first one. What's the next one, Ellen? 1
equals 2 plus
Okay.
2a.
Be careful about that.
Yeah.
Look carefully. an squared. So if you plug 2 in n, it's going to be 2 squared. 2 squared is what? 4. 4a plus what? What?
2b.
2b plus, yes. And the last one?
0.
0.
Equals 3a.
Okay, again, look. It's not n, it's n squared.
9.
Yes, 9a
Plus 3b.
plus 3b
Plus c.
plus c. Okay, 1, 2, 3. You see, it's a 3 by 3 system equation. 3 variables, 3 equations, which means all the variables A, B, C can be solved. Okay? Whenever you have the number of variables equivalent to the number of equations, it's telling you that this system equation can be solved. A, B, C can be solved. How are we going to solve them? Okay. Is it okay for me to erase this part?
Yeah.
The left part? Okay. Because I need this space, the whole space. Never mind. Okay, so the chord to solve says, Okay. Remember two concepts when you solve system equation. Two keys in solving system equation. Equations. Number one, you want to reduce the variables. Number two, you want to reduce the equations. If you have more than two equations, the first thing you need to do is to reduce the three equation into two equations. How would you do that? I'll give you time to think about it. Okay, 1, 2, 3. We have three equations now. And the goal for you to do is to reduce the three into two equations. Think about how would you do it.
Calculate the C using first.
Calculate which C from which equation.
The first one.
Okay, then what?
And then substitute the C from the other.
To
yeah.
tell me the number. Tell me the number. To which equation?
Equation 2 and 3.
Okay, got it. Did you see? Did you hear that?
Yeah.
So you figure out a way to use C to represent, no, to use A and B to represent C, which is make C the subject. C is equivalent to 4 minus A minus B. Does that make sense to you?
Yeah.
And you see they all have C's in 2 and 3. And what you need to do is you just replace the C with the later part. And then you're going to have how many equations? Two, only two. Now you just changed a 3 by 3 equation into 2 by 2 equation, which is simultaneous equation. Good, very good. Now let's do it. So, okay, I'll just start over here and say from 1, you get C as equivalent to 4 minus A minus B. Minus B. Let's give it a number. Let us say 4. Okay? Because you don't want to write the whole equation repeatedly, just a waste of time. Substitute 4 and 2 and 3. Okay? If you substitute this 4 and 2 and 3, what do you get? If you just replace the C with the value here, it's no longer C, it's 4 minus A minus B. The whole equation changes to what? Elijah? I'm going to write 1 is equal to 4A plus 2B plus 4 minus A minus B, which is equal to what?
3A.
1 is equal, okay, simplify, 3A
B
plus
B
or minus?
plus B
Plus B
plus 4.
plus 4, okay, 4, 1. How about let's just move all the constant to the other side? How about let's just move all the constant to one side?
4 minus 1.
Will be negative 3, right?
Yeah.
Okay,
No, it's 1.
that's correct.
4 minus 1. Oh.
You got it? Okay, now good, great. Now let's substitute this part over here, and you got a C is no longer C, is what? 4 minus A minus B. Now the whole equation changes to what? P and
0
0
equals
equals
9A plus 3B
9A plus 3B
plus
plus
4 minus A
4 minus A minus B. Great. Now simplify it. Combine the like terms. These two are like terms. This is like term. These are like terms. what's your final equation then?
8A
8a
plus 2B
plus
2B
2b
plus 4.
plus 4 is equal to
Oh, 4 equals 4.
-4.
negative 4. If you put 4 on the other side. I mean, plus 4 is also correct, but we're just trying to get the same structure.
Oh,
So let's just put all the constant to the other side.
also 0 minus 4, so it's
Minus 4. Okay, you got two more equations. These two are 2 by 2 system equation, simultaneous equation. You know how to solve simultaneous equation, right? Okay, let's just give it numbers. We get number 4. Now let's just give it number 5, number 6. Okay? It's getting, I don't know, do you know the Russian toy? Like, you open it, there's another toy, and open it. It's like that, nesting, right? Now, from 5. From 5, what do you get? From 5, what would you get? Which number you want to substitute?
B.
B. B is equal to what?
Equals to
Minus 3 minus 3a, right? And let's give it a name. Let's say 7. It's getting crazy, right? Okay, all these numbers are actually helping you to remember these are equations. You don't want to write too much, too long, right? That's actually helpful. Sub 7 in 6. So if you sub 7, you're going to replace B with what? If you're going to replace B with this part, then you get what? 8a plus 2 times what?
2 times minus
3
minus 3.
Yes, correct. Okay, can you simplify it? You can, okay, if this is one equation, one variable, which means you can get the A solved. Alright? But how are you going to solve it? It's going to be
Yeah.
8a, just tell me, just expand the brackets.
Equals -6 minus -6a.
2a is equal to, you're going to move 6 to the other side. Plus 6 on both sides give you
2a equals
negative 2 or
positive.
positive 2. A is equal to what?
1.
1. Okay.
How's it? Oh yeah.
You got it? Now we got a one variable solved.
Yeah.
And now,
Oh.
Now we have to do that again.
yes, we have to. Okay, since you get a one variable back, you get a one variable solved, you just need to plug it back, and get a variable, all the variables.
Okay.
Okay, now let's say plug A is equal to, Sunny, where do you want to plug your value for A?
The first equation.
Huh?
5.
5, okay, here. 5. That's why we need the numbers.
Yeah.
In 5. And you have the equation of what? 3 times 1 plus B
equals negative
3. B is what?
B is 6. No.
-6. Wait.
Yeah, minus 6.
Yeah, minus 6.
Minus 6.
Yes.
Minus 6. Okay, you got the value for A, you got the value for B, and you need to solve the value for C. Do we do it? No, I don't think so.
We just removed it.
Yeah.
Completely solved it.
Okay, then how can we solve the C?
Yeah, you also plug in A and B to the first, second order.
Okay, good. Did you hear that?
Yeah.
He's gonna plug 2 numbers in which one?
Let's say 1.
1. This one.
Yeah.
If you got 2, okay, you're gonna have one variable in one equation, which means the problem can be solved. Yeah, linear. plug A is equivalent to 1, B is equivalent to minus 6 in 1. And then you have the equation. Tell me what the equation looks like.
4
4
equals 1
plus
negative 6
negative, which is 1 minus negative 6. Just make
plus C.
plus C. C is equivalent to
9.
Yeah.
correct?
Yeah.
Okay. Now you got the value for A. You got the value for minus 6. You got the value for 9.
Yes.
What's the formula again? UN is equivalent to A.
n squared plus bn plus c.
Okay. Now how about I just plug them all back in?
Yeah.
You don't have to write it down. Just simply plug them all back in. UN is equivalent to
1.
n squared.
just n squared
plus
Plus
negative 6
negative 6n
Plus
9.
plus 9. Okay, this is the formula. Okay, we spent the whole whiteboard to get this formula, right? Okay, the textbook mentions a simple way. But you're gonna forget that formula. Good question. Why don't we use a simple way? Because you're gonna forget that. Anyway, it doesn't explain why the formula comes from, but anyway. So we need to know if the formula is correct. How do we know it? Just simply plug one. Okay, if I ask you what's the fifth term? What's the fifth term? When n is equivalent to 5, your un becomes what? I want to know what's the value for fifth and
5n squared.
25
minus 30.
minus 30 plus 9, which is what?
Negative 4.
4. Okay, let's see if that's correct. 1, 2, 3, 4, 5, 5. Okay, now, finally, right? Okay. Okay.
One question.
We're gonna do more practice next lesson, okay? Just keep that in mind.